Training.com, CWI prep course. Come visit us at our website at train-eng.com, pronounced training. This is our CWI prep course. This is as you go through some of these videos, these will be some snippets or samples out of our online training course. If you like what you see here in the sample section, come and visit us and take the course. Unlike a lot of other programs, we've got it set up so that you can do it a la carte. If you only need to, we've got different parts of the CWI course broken out. So if you don't need to sit through and take safe practices for welding inspectors, or you have some strengths that you know of and you want to streamline the process and only hit the sections where you don't really have a strong background or a great deal of proficiency, our program is set up so you can take some of these parts of the CWI online course a la carte. Pick and choose, put together what you want. Leave the rest, like a Chinese food buffet. CWI prep course, destructive testing, module 6, part 5. Learning objectives. In this module, we're going to touch base on intro to destructive testing and tensile tests. Destructive testing. In procedure qualification testing and welding development work, mechanical test specimens are removed from a test specimen to check the quality of the weldment. These tests are used to determine mechanically the properties of the weld and base metal. Mechanical properties of materials are measured by a variety of mechanical tests that simulate conditions materials must stand while in service. The most common of these tests are the tension test. This test measures the tensile load carrying ability and the amount of deformation a material can withstand before rupture. Hardness test. This test measures the ability of a material to resist indentation or penetration. Sharpie V-notch test and fracture toughness test. These tests measure the ability of a material to resist fracturing in the presence of a notch or a crack. The creep test. This test measures the amount of continuous plastic deformation of a tensile specimen over a period of time. The fatigue test. This measures the ability of a material to resist breaking when subjected to a fluctuating or alternating load. Mechanical testing. There are several different sources for mechanical testing methods. AWS B 4.0 M 2000 standard methods for mechanical testing of welds. There's several ASTM standards. There are several different sources for acceptance criteria, including construction documents and qualification documents. ASME Section 9, AWS D 1.1, Structural Welding Code for Steel, API 1104, Welding of Pipelines and Related Facilities. You can see there's a lot of different places where you can receive your direction from. You just need to realize which area you're working in and what are the contract documents and qualification documents. I've got some experience in oil and gas, and a lot of times your big companies, the BPs, the Shells and whatnot, will have very specific acceptance criteria for, bend tests or tensile tests or yield strengths of materials or whatever. But they're written in there. They'll give you a construction document specific for that project, and it'll say ASME Section 9, and we want this, this, and this done. So for mechanical testing, just realize that there's a lot of different acceptance criteria, and you need to make sure that you're swimming in the right pool for what you're working on. Mechanical testing. We're going to take a look at testing methods covered in this module. Hardness testing, tension testing, bend testing, fillet weld break test, and fracture toughness testing. Tensile tests. Tensile tests are conducted using specimens cut from a test weld and machined to one of several standard sizes for mounting in a testing machine. Specimens are usually taken perpendicular to the weld, with the weld centered in the specimen as shown in Figure 15-6. However, specimens are sometimes taken parallel to the direction of the weld and consist entirely of weld metal. Specimens may have round or rectangular cross sections depending on the requirements of the applicable welding code. The testing machine applies a tensile force on the specimen till it ruptures. From readings on the machine and measurements on the specimen before and after the test, properties such as yield strength, tensile strength, and ductility can be calculated. The primary purpose of the test is to demonstrate that the weld metal deposited by the selected procedure meets or exceeds the minimum values of specified in the applicable code. So basically, you're making a weld, and then you're taking a slice out of that weld, and you're machining it down, putting it in a tensile tester, pulling on it, and making sure that the strength of the weld metal is equivalent or higher than the base metal. And this tells you what you need to know. You can get yield strength, tensile strength, and ductility out of this one set of tests. So tensile tests are a pretty good tool to have in your tool bag. Tension test, summary of method. Okay, for the tension test, we've got on the left, we've got the test coupon in the loading grips. So to figure out what the stress is in PSI, we'll use PSI because I think in PSI, the American/English system, you take your load, which is how much force it takes to make this specimen fail, and you divide it by the initial cross-sectional area. So 100,000 pounds divided by 1 square inch, it'll give you 100,000 psi is your stress. Your elongation divided by initial gauge length is the strain. So you take your gauge length and then you figure out how much elongation there was, and you divide it by the initial gauge length, and then that's your strain. Pretty easy math, pretty cut and dried. The tension test. Summary of method. Tension testing of welded joints is done by means of a calibrated testing machine and devices. The test sample is pulled in tension until the sample fails. The significance. Tension test provides information on properties of welded joints, load-bearing capacities, joint design, and ductility. Here's a couple of tension test apparatuses. On the right, you can see a conventional loading system for tensile strength only. This is like the old school stuff from the 1950s. I don't know, 1950s, 1960s. This is what they had when I went to college. And then on the left, you can see a modern loading system that's computer controlled, and it'll give you a significantly larger amount of data than maybe the conventional loading system would. But you'll run across both, just depends on where you're at and what you're looking at. Both are quality ways to achieve the data that you're looking for or not looking for. Tensile test specimens. You can see that we've got an all-weld metal tensile test here. You can see the red dot on the top illustration is where the tensile test was cut out of the weld. And an all-weld metal tensile test is used to determine weld metal ultimate tensile strength, yield strength, elongation, and reduction in area. The reduced section tension test determines the ultimate tensile strength only. Specimens shall be tensile tested in the as-welded condition unless the procedure qualification requires a post-weld heat treat. So what's this telling is that you can't do a weld test, do a test coupon, and send it to heat treat, and then pull the samples, and then and then the samples pass, and then you go out in the field and you're going to use that procedure without post-weld heat treat. If you have a procedure and you use post-weld heat treat, all the welds have to be post-weld heat treated. This slide shows an ASME Section 9 QW 150 tension test. So if you get thrown out in the field and you need to qualify a weld procedure and you don't know what size the tension test needs to be, you go and you're qualifying the welders and the procedure, well, in this case, the procedure to ASME Section 9. They've got a little recipe book with pictures and dimensions, and it'll tell you exactly what you need to do. Sizes, what it needs to look like, it walks you right through it. So it's not, none of this stuff is rocket surgery, and then once you become a CWI, there's information out there that guides you through the whole process. So it's not like you have to commit this stuff to memory. Here's another slide. This one is a reduced section tensile test for pipe. Same thing, it walks you through it, talks about grinding the minimum amount needed to obtain a plane parallel face over reduced section. It walks you through everything. Like I said, none of this stuff is really rocket surgery, and you don't have to commit it to memory, but you do need to be cognizant that this material exists and that it's out there and you just need to find it. I don't remember any of this. I just know where to find it and look it up. I don't have it committed to memory in some kind of savant type fashion, but I do know where to find it and go dig it up and, you know, let people know what you want done as far as what tests you need done to qualify your procedure. Summary. In this module, we covered Introduction to Destructive Testing and Tensile Tests. Our CWI, CWE Online Part A video course, $149. It's self-study CWI exam. Everything's an online video course. We've got one section where it's questions, questions, and more questions. We've got a whole number of CWI self-study question bank, $40. Come on in, take it, take a look, see. If you just need questions, if you sat through another course and you just want to keep hitting the material, check out our question bank, $40.